Hi, David Tubb here. We're here today to talk about the dynamic targeting reticle in this scope. Dynamic targeting reticle, or DTR, it allows you to, on the move and as the atmospherics change, figure out what your effective hold point is. I've got this set looking to the sky right now, so we're running a couple of images here. When you look at the dynamic targeting reticle, you see a great big horizontal line. That is your 200-yard zero line. There's a dot in the middle of that line. Of course, there's running and walking leads and 20, 30, 40 mile per hour leads. It is horizontal or level to the world, just as that milk count graph above it is. We'll cover the milk count graph in other segments. To keep in mind, this reticle is designed, we'd make them in yards, and we do them in meters. This particular one today is great with a 300 Win Mag with either 220s or 190s. It's also very good with 7mm 180 grain Burger bullets and Sierra bullets. Either one, very good. It's also good with 175 7mm, so you could use it for a hunting cartridge very easily. Today we're shooting a 6XC, which is a cartridge I developed with 115 grain bullets, DTAC bullets. Works very well with that also. The thing to know about these scopes is they have an operating range, a velocity range, and somewhere between 250 and 300 feet per second is the operating range. So if we took, for example, the 308 scope, and if you had a 308 that shot 175 grain Sierra bullets, and you shot them from 2,400 to 2,700 feet a second, this scope would work very, very well for your application. And to look through the reticle, obviously we've talked about the horizontal bar being square to the world. You see the array of dots that transverse down, all right? And it's really not very hard for you to figure out how to use the scope or to teach this to somebody, because if I want to shoot a shot at 600 yards, it's not going to be very hard for you to figure out where a 600-yard hold would be, or an 800-yard hold, or a 1,000-yard hold. Now, obviously, the gun, scope, reticle, ammo combination have to fit the atmospheric condition, which we will cover. But you would know where to hold. The main thing, or one of the main things about this particular scope, is we account for the precession or the spin drift of the bullet in each of the respective calibers. So that means when you shoot a shot at 100 yards or 600 yards or 1,000 yards, you have a true no-win zero. If you've been around all your life of a square crosshair, it's truly almost the furthest thing from the truth, other than the fact that it's good for one distance and one wind condition. So if we shot at 100 yards with a regular crosshair and then shoot at 1,000 yards, our point of impact with a right-hand twist gun is going to be at least 10 inches right in a no-wind condition. So the simple fact that you have a true no-wind zero at each yard line is a big deal. Obviously, we have a level on this scope, and it's very important to level your gun. So you'll never see us do that as we go through this today. The other thing, if you look at the dots, and let's say 600 yards, you can look in there, you can see the 600-yard line, and there's a 6 in the middle and 6 on each end. You see the dots that move out incrementally right and left. Those are 5, 10, 15, 20, 25 mile an hour wind drift dots at a specific air density. If you'll notice, they're angled, and that's because there is a vertical component to a crosswind. McCoy called it aeronautical jump. We call it crosswind jump. I think it's a much better term for a shooter, because that means if you've got a crosswind from the right or the left, your bullet is going to climb or fall. And typically, most everybody who's done the testing, depending on the gyroscopic stability of the bullet, the rise or fall is basically every 2 dots in there, which would be 10 miles an hour, 5 on each side, 10 on each side, would lift or make the bullet go down by about 0.4 of a minute of angle. Okay, so at 100 yards, 0.4 of a minute of angle, it's 0.4 inches. Okay, that's a big deal if you're trying to shoot a little prey dog head or trying to shoot a paster on a target. Additionally, in there, we've looked at and shot this enough that we've accounted for what they call the boundary layers of airflow. And that means if we shoot a shot at 600 yards through this scope, and I tell you it's a 5 mile an hour wind from the right, then you obviously know at 600 yards that you're going to use one of the dots, one of the windage dots, because they're 5 miles an hour. So you hold into the wind with the 6, so it'd be the first dot on the left, and you shoot that shot and you get a hit, and let's say about that same time another target appears at 900 yards. You already know your wind hold on that same sort of vector angle. Okay? You're going to hold 5 miles an hour. Now the whole premise of all this stuff and all this scope and the ammo and atmospherics are in a ballistics program. You got a bullet, you got a center line over bore height, you got a velocity. The bullet has a coefficient, how it slows down. There's plenty of ways to measure that. And then the other factors that influence your flight of the bullet to the target, other than the bullet flight phenomenon we're talking about, which was the wind and so on and so forth in the Earth's rotation, are, the main ones are temperature, pressure, elevation, humidity. You combine all those, or what do you do if the pressure changes 2 points or the temperature changes 15? So sometime back, years ago, when the pilots tried to figure out how they could predict the atmospherics, they came up with a thing called density altitude. Icao, International Civil Aviation Density Altitude. And what they do is they are able to combine that temperature, pressure, elevation, humidity into a single denominating number. And basically, you'll hear us talk about a 4,000 foot density altitude or a 0 kDA day, or a 1,000 foot DA, or a 1 kDA, it's the same terminology. So if you hear me today, well, we've got a 3 kDA day, that means we have a 3,000 foot density altitude day. And when you relate that back to the pilots, if one of them took off in Phoenix and knew his airframe, and basically he was going to land in Virginia Beach, it's going to have completely 2 different elevations and 2 different temperatures, but the air density is what he's really concerned about. So what we're doing with density altitude is we're planning the flight of the bullet to the target. And yes, you can have a -1 or a -2 kDA day. Obviously, if you get where it's real high and it's really warm, you can get a 12 or a 14 kDA. But most of the time, we're going to be dealing with somewhere between a 0 kDA and probably an 8. All right? In addition, back to the reticle. When you look at the reticle, some people would say, okay, it looks like a Christmas tree. Well, it really looks like a crooked Christmas tree, because the main beam and the dots are on a parabolic curve. They move to the right for the precession of the bullet. The dots are angulated for the crosswind jump, the vertical component. They're also designed to be for the boundary layers of airflow. So if you shoot a target at 500 yards and this far off the ground, and you shoot a target at 900, and then it goes another, let's say the apex of the bullet is 8 feet high, the wind's going to move it a little bit more, but you hold the same amount. We also account for what we've tested and found. There is a small amount of difference between a right-hand wind and a left-hand wind as far as what moves or how far it gets moved. That's programmed in this scope. This scope's available in 223 for like 77s. Obviously, this scope works for the variety of calibers we talked about. We make a 308 scope in meters and in yards, and one for a short barrel rifle would have a slower velocity. So you go, how's this work? Well, if you look at one of these caps around the top, when you get your scope, you get 2 or 3 of these when you buy a scope, or you get a windage cap that's got it written on there. It has velocity assignment values for your rifle based on the gun's velocity, based on the bullet you're shooting. So if you look at it and it says, okay, if this gun goes 2975, then it is a 4 kDA gun rifle ammo assignment value. So if I said, okay, it's a 4 kDA gun, and we have a 4 kDA condition on our Kestrel, then you'd shoot, if I said shoot 600 yards, you'd shoot 600 yards. If I said shoot 800 yards, you'd shoot 800 yards, and you'd hold the wind thereof. But let's just say it's not a 4 kDA atmospheric, okay? Let's say that we're in something different, all right? We're going to call it a 4 kDA condition right now. That's what my Kestrel told me we were going. We're like 3,800, temperature's going up, so 3,800 feet, I'm going to round it up to 4,000. And this particular rifle gun scope ammo combination this ammunition goes 3,075 feet a second. So it's assigned, if you look at the ring, a 0 KDA value, nominal value, all right? So if we look at 700 yards and we measure the distance to a target, and let's say it's 705 yards, and we're going to shoot this shot with a 0 gun and we have a 4K condition, we obviously have to know those two items, and obviously 0 minus 4 is minus 4. That's my factoring number. Okay? That means that's the difference between what my gun is and what my current condition is. But then how do we apply that to shoot a 700-yard shot? Well, if you look to the left of both of the 7s, out to the left, and you look all down that whole angled aiming mark array, you'll see lazy numbers out to the side, laying down, and they're what we call ADC, air density correction numbers. So if you look at the one at 700 yards, you're going to see it's a 5. So that means for every 1 KDA or 1,000 foot of density altitude change, my gun's either going to shoot 5 yards closer or 5 yards further. Because if it's a positive number, I've got to hold further, and if it's a negative number, I have to hold closer. So right now we got a 0 gun and a 4 condition. 0 minus 4 is minus 4. Minus 4 times that 5 is minus 20. So that 705-yard target, I have to hold 20 yards closer. So that means if I subtract that, I hold 685 yards. And at this point in time that I hold 685, the fact that the time of flight of the bullet to the target is as such is the spin drift and the crosswind jump and the boundary layers of airflow and the dissimilar wind drift, they all align themselves. So we're going to shoot a couple of shots to 0. Then I'll give a little bit more demonstration on how we're going to use this and when it matters and when it doesn't matter. And we'll shoot some targets. Now I run this on about 10 power. This is a GoPro through a little prismatic thing that Torrey Pines makes. It's really kind of cool. Get to see what I'm seeing when I'm shooting. All right. I also have a laser rangefinder on this gun, all right? And it is set to the 200-yard aiming dot. So we'll use it in a little bit. So here we are. This is a 200-yard target. And I know it's hard to see stuff down there. I'm going to try to focus it so it's clear. I'm actually going to run the power up. And we're going to shoot most of this video on a lower power. Trying to make this as clear and useful as for you guys can see this. I level my bubble. Remember, this gun goes 30-75. We did that with a magneto speed chronograph. We're going to shoot at the black, left of the black, there's a number 8. You can see the 200-yard dot. Here we go. All right, let's see if we can see the shot. Okay. We hit the top circle of the 8. All right. I'm happy with that. All right, I'm going to bring it back down to about 9 power. Get this focused right there. All right. So here we go. We're going to shoot a target. Now, most of the targets out here are 2 feet tall. All right, and there's several milling and ranging abilities of this scope. I'll show you one right quickly. If you look here on that yellow-headed target, when I put, that's a 1 foot ranging graph, all right? So it's 1 foot wide or 1 foot tall, depending on what the target is. So if I put that in between, in the middle of that target, that bottom bar, you see that yellow-head subtends between the 3 and the 400 yards. So I could safely assume that that was a 350-yard target. Now, if you look, and so we'll shoot this target. And if you look, 300 is pretty easy to see. You see that triangle in the middle between the 3s, and you see that diamond in the middle between the 4s. Well, 350 is right in the middle. By the way, all these 5-mile-an-hour incremental dots go all the way down at 200 and 250. They're 10 mile an hour. We try to keep it from cluttering everything up. So we're going to put 350 yards on the middle of this target. The other thing to know while we're doing this, here we go. Got the gun level. We're going to shoot it in the middle of the head. Yeah, shot it just on the left edge of the head. Pretty good shot though. One other thing to know, if you look at that 100, 200, 300, 400, there are no air density correction numbers out to the left. See? It starts at 500 yards. So that means if this gun goes anywhere from 2850 to the 3075 and you zero the gun at 200, you're going to hit under your dots until you start getting to 500, where it starts making a difference. And obviously, look out there at 1,000, it's 9 yards for every 1 kDA change. Okay. Now remember, we have a zero gun and we have a 4K condition. First target we're going to shoot is a yellow-headed target. I'm going to put my laser 200-yard dot on it. Hit the laser rangefinder. It says that target is 715 yards away. All right, 715. So we have a zero gun, and we're in a 4 condition. 0 minus 4 is minus 4. So at 700 yards, if you look over to the left, minus 4 times 5 is minus 20. So 715 minus 20 is 695 yards. So I'm going to try to shoot this target in the head. 695. Here we go. Looks like there's a little bit of left to right wind, all right? So I'm going to hold about a mile an hour of wind. Didn't need it, did I? Shoot 0. There you go. A little on the right side of the head. Just a bit. All right. We already know we're going to hold 0 on this target. I pinged it. It's 913. Okay. 0 gun. 4 conditions. 0 minus 4 is minus 4. At 900 yards, it's an 8. Minus 4 times 8 is 32. 912 from 32 is 870. 870 yards. Here we go. There's 850. There's 875. There you go. In the head. Anyway, all right. Here's another one. Yellow target. 990. All but 1,000, right? 0 gun, 4 conditions, 0 minus 4. It's negative 4, 1,000 yards, negative 4 times that lazy 9 that is put on the target. 36 yards off, right? So 36 from 990. What? 954. Here we go. 954. Let's see if we can get him in the head. 954. In the head. All right. One more. Needed about a mile an hour left to right. Says 1,100 yards. So 1,100. See that lazy 11? 0 gun, minus 4 or 4. 0 minus 4 is minus 4. Minus 4 times 11 is minus 44. 44 from 1,100, 1056. I'm going to shoot this target in the middle. 1056. Here we go. 1 mile an hour left to right wind. Got him. Just a little right of center. Maybe a mile and a half of wind, okay? All right. Now, what do we do if we don't have a 0 ammunition? All right? Let's change this. I also have some 3,000 foot ammunition. So if you look on your little cap or your little knob on the side, you're going to go, okay, I have 3,000 foot ammunition. So that means I assign that gun, ammo, rifle, scope combo a 3 kDA. All right? So we have 3,000 foot ammo. So 3 minus 4 is minus 1. So back to that 700, and let's see what it was, 715, I think it was. Here we go, 715. 715. All right, we have a 3 ammo in the gun now because it goes 3,000 feet a second instead of the 0 ammo that we 375. Tells you on your scope count. So 3 minus 4 is minus 1. Minus 1 times that 5 out to the left at 700 yards is minus 5. So minus 5 from 715 is 710. So 710 yards is my effective hole point. So I'm going to shoot it in the middle of the body. Less wind right down there. 710, here we go. See that? Shot just on the right side. Still at 1.5 mile an hour, 2 mile an hour wind. All right, let's go with another one. Let's go back to that 900, and what was it, 12? 912. 912. All right, 3 gun because it goes 3,000 feet a second. Minus the condition of 4. 3 minus 4 is minus 1. Minus 1 times that 8 I see there, all right? It's minus 8. 912 minus 8's 904 is my effective hole point. Here we go, 904. 1.5, 2 mile an hour left wind. Here we go, 904. See that? In the middle, just a smidge, yeah. Still a mile an hour wind running down there. So, to surmise this reticle, if you learn how to run what your ammo is, your gun velocity is, there's several ways to determine that. If you know how to use this reticle, like I'm showing you, and you don't have to spit out the calculations yet, I'm trying to teach you. This is the fastest reticle once you use it that you can ever encounter, and it doesn't fail because there's no electronics. Okay, I'll show you how to range and stuff. Obviously, there's a laser rangefinder on it, which is an electronic, but inside this scope, it has its own ballistics program, and so you have an assignment value of this gun from, let's say, a 0, like this ammo was 0 KDA, and we can have some ammo that we assigned a 9 KDA. But the simple fact is if you know your gun, ammo, the gun, the ammo, and the velocity, and you know what the current conditions is, and you can add or subtract numbers between 0 and 10, and multiply it, and then take the negative portion and hold closer, or take the positive portion and hold further, to determine your effective hole point, then you have your own ballistics computer in the scope. So the thing is you notice we never touch the knobs. When we zero the gun, we either leave them alone or screw the scope caps on them. That's because you're calling the distance in yards, or you're measuring the distance in yards, and you're figuring out what your effective hole point is in yards. You're also coming around and you're calling your wind in miles per hour or vectored miles per hour, and you're holding your wind in miles per hour. There is absolutely no conversion from the distance to a mil hold for elevation or an MOA hold for elevation, and there's absolutely nothing in there for a conversion for the windage hold to a mil hold or an MOA hold. There are absolutely no wind formulas you need to learn, other than the fact is how fast is the wind blowing, and what is my vector angle, and so what's my percentage. Obviously today it's pretty calm. We're holding 1 or 1.5, maybe 2 miles an hour of left to right wind. On the days though that the wind gets up, this is an invaluable tool. Because like I said before, if you shoot a shot at 600 yards and you held 5 miles an hour of right to left wind, so you held the first dot to the left to center, and you see the shot at 900, and you shoot another shot at it, you already know your wind hold. As opposed to, oh, I held a mil at 600, now I want to hold 2 mils at 900, goes backwards. There's a lot of other stuff that this scope will do, and obviously we also issue, when you get one of these scopes, you get a ballistics program that at this point in time you can run on your iPhone. There's also obviously a very detailed instruction manual and a one-page instruction manual. There's been a lot of thought go into this. I've worked several years. There's several patents involved. But I will tell you, when you are in an active shooting environment and you need to shoot fast and you need to get a hit, because I'm interested in trying to hit a postage stamp, not an E-type silhouette. And all in all, watch for us. We're going to have various segments on this. We'll have a milling segment or a ranging segment. I kind of showed you how the 1 foot graph worked. We'll cover that in a segment. We'll have a moving target segment, because if you shoot at a target at 600 yards and you don't hit it, guess what? It's moving. And you're able to engage moving targets really with ease out to about 800 yards with this scope. If you look in there, there's running and walking leads. Anyway, watch that, and then keep your eye open when I go baboon hunting. Baboon hunting is the most cunning hunting that I've ever seen, because they're very smart. They move. They traverse up the hill. If you have to come out and dial your knob or look at a ballistics program, you're going to be lost. One other thing. We talked about the ballistics app that comes with the scope. You don't need the ballistics app if you shoot the right bullet, the right velocity, you're great. But if you want to shoot a BB gun with this scope and you have my ballistics app, you can do it. So it gives you the ability to use this gun on your favorite rifle and or build one, and or if you want to take it off and use it on a other caliber rifle, let's say a 223, you can use this. It doesn't work as well, obviously, but it is usable. Look for us on the web at davidtubb.com. There's lots of videos. I try to make exceptional products.